So I have just explained you the notion behind the utility. Okay, so to specify the utility, the agent needs some utility function. Okay, and we know that in case of a agent, the agent moves from one state to another state. Okay, and in each and every state, the agent is expected to take some action depending upon the inputs, depending upon the percept. So agent preferences between different states can be captured by utility function. The utility function is specified by U and S is the state. So in case the utility value of state I is greater than the utility value of state J, then the agent will prefer to go to the state Si than to the state Sj. So if there are two options for the agent, one is Si and Sj, which are the two possible states the agent can move to. So if the utility of state Si is greater than the utility value of this Sj, then the agent will prefer to move to state Si than going to the state Sj. And in case the utility value of both the states Si and Sj is same, it means the agent is going to be indifferent. The agent will not be able to differentiate between the state Si and Sj. Okay, and in that case, the agent can either go to the state Si or Sj. Right. So this utility function is basically there with the agent to determine the utility of a particular state. Okay, so what we are supposing? We are supposing that the agent will select the state corresponding and its corresponding action that will maximize the expected value of that particular action. And how do we calculate the expected utility of a certain state and its corresponding action? This is given by this formula. So what is this formula? Expected utility of A, action A, given the set of inputs E is the set of inputs or E is the environment information available to the agent, equal to summation of all I such that probability of result of I of action A. Okay, so agent would be knowing that what could be the possible action, what could be the possible result of this action A, right? And after performing the action A, the agent notes that there could be multiple states possible, so it will calculate each and every possible result because of this action, such that it performs the action A given the set of input C multiplied by utility of result of A. So basically it is the probability of result of A and utility value of result of A, and this I will be over all the states which can be possibly derived after the agent takes this action A, right? So this is the way the utility value, expected utility of a certain action will be determined by the agent, and agent will select the action that will give the maximum value of this expected utility. So if there are different actions which are supposed to be performed by the agent, so agent will calculate this expected utility of that particular action, and then after it will select the action corresponding to the maximum expected utility, right? So the result IA means all the possible states which can be resulted after taking the action A by the agent. Okay, so if there are two actions, there are some rules of this utility theory. So for these rules, there are some terminologies which are used here. So if I write action A and action B, A is greater than B, it means that action A is preferred than to B by the agent. So in case the utility expected utility of A is greater than the expected utility of B, in that case we will say that agent is preferring the action A than compared to the action B. And if the agent is indifferent between A and B, then we will write like this. So A tilde B, it means that the expected utility of both the actions A and B is same, and that's why the agent does not distinguish any difference between A and action A and B. A greater than equal to B means the agent prefers A to B or is indifferent between them. So either the agent will prefer A than compared to B, or the agent is going to be indifferent between A and B. There is a other term which is described here, that is called a lottery. Okay, lottery. So what is a lottery? Lottery is nothing but a sequence of a number of elements where each element is a pair of two things. So each element is a pair of two things. So P1 comma C1 is one pair, P2 comma C2 is another pair, and it could be up to Pn comma Cn. So where each pair is having two elements, one is the probability, and C1 is the corresponding reward. Okay, so there exists a probability for that particular action and the corresponding reward. So P2 is another probability and the corresponding reward. Pn is the another probability and the corresponding utility, or you say the reward, right? So a lottery is always described like this. So there are okay. So we will see what does it mean actually. Okay. So what does it mean by orderability? So if there are two actions or two states, okay, in that case, either a rational agent will prefer one of them depending upon their utility value, or if the utility value of these two are same, then they can be equally preferable. So it means that either A is greater than B, or B is greater than A, or A is indifferent to B. So depending upon the expected utility value of A and B, the agent will either prefer to take A then compare to B, or the agent can take B then compare to A, or if the utility value of A and B are same, then agent can use either A or B. In that case, they are supposed to be indifferent. So this tilde sign is for indifference. There is no difference the agent finds between action A and action B, or state A or state B, right? Now, what is this transitivity rule? If there are three states and we say that the agent prefers A to B, and at the same time agent prefers B to C, it implies that agent will prefer A to C. So if the expected value of A is greater than the expected value of B, and at the same time the expected value of B is greater than the expected value of C, then it implies that the expected value of A will be greater than expected value of C. So in that case, the agent will definitely prefer A to C, right? So this rule is actually known as the transitivity rule. Then we have another rule that is called the continuity rule. Continuity rule. Okay. So if A is preferred over B and B is preferred over C, then it implies that there will exist some value of probability such that A is the action with the probability P and C is the action with the probability A minus P is indifferent to B. Is indifferent to B. What does it mean? If we say that we have three states A, B, C, and we have some state B between this A and C in the preference order like this, then there will be a probability P for which the rational agent will be indifferent between the state B and the lottery in which the A comes with probability A and C with probability A1 minus P. So it means that if we have this sequence of preference between A, B, C, then this A with the probability P, this C with the probability 1 minus P is going to be indifferent with respect to B. So this is the rule that is known as the continuity rule. This is known as the continuity rule. Then we have the another rule that is called the substitutability. That is called the substitutability. So if the agent is indifferent between two lotteries A and B, then there is a more complex lottery in which A can be substituted with B. So if A is going to be indifferent with B, then it implies that there will exist a probability P with A and 1 minus P with C, and this is going to be indifferent with respect to the probability P with B and 1 minus P with C. Right. So this rule is actually known as the substitutability. It means that A can be substituted with B. A can be substituted with B like this. Then we have this monotonicity property. If the agent prefers A to B, if the agent prefers A to B, then the agent must prefer the lottery in which A occurs with a higher probability. So if there are two actions A and B, two lotteries A and B, and the agent is preferring A with respect to B, then it means that there will exist probability P and Q such that the probability P with A is going to be greater than probability of Q associated with A, because A is preferred over B. So A would be having greater probability than compared to the other probability associated with the A. So this rule is actually known as the monotonicity rule. Then we have this last rule, decomposability. The compound lotteries can be reduced to simple lotteries using the law of probability like this. So if we have a lottery like this, and we have A with the probability P and 1 minus P is the probability associated with this, then it can be decomposed like this. Right. So we are not going into the very much detail of these rules. Okay. So all these rules are supposed to be true, and that's why they are called the axioms of this utility theory. So what is a lottery? I have told you. So I've told you lottery has pairs like this, and each pair is a combination of two elements. One is the probability, another is the outcome, or you say the utility or the reward. Right. So this is written like this: probability A, colon A, comma 1 minus P C. So if there are two outcomes in a lottery, A and C, if A is having the probability P, then C will be having the probability 1 minus P. Okay. So you see in the last rule, this is the rule for compound lotteries. So what is this compound lottery? You see one rule, probability A associated with A, and 1 minus P is the probability associated with this. Okay, and it is basically the combination of two things. There is outcome B and there is outcome C. So 1 minus P is further divided into Q and 1 minus Q. So this can be broken down into two simple probabilities like this. P, probability P associated with A, 1 minus P into Q associated with B, 1 minus P multiplied by 1 minus Q associated with C. So this is what the simple lottery. So you have this simple lottery. You have this A, B, and C. So there are three outcomes: A, B, and C. Or you can say there are three actions or outcomes or three rewards in this lottery, and which are having the probability P, 1 minus P into Q, and 1 minus P multiplied by 1 minus Q. Any doubt into this? I think it is clear, all of you. Okay. So all these are actually known as the axioms of the utility theory. Okay. So what happens? The agent is supposed to obey the axioms of the utility theory. So in that case, if the utility of A is greater than utility of B, then the agent will prefer A than compared to B. If the utility of A is equal to the utility of B, in that case the agent is not able to distinguish the difference between A and B. In that case, the agent can either choose A or it can choose B, right? And how do you evaluate the utility of this lottery? The utility of the lottery is the expected utility. So if you have if you have this lottery in which there are two outcomes A and B with the probability P and 1 minus P, then the expected utility of this lottery will be given by probability of A multiplied by utility of A plus 1 minus P multiplied by the utility of B. So in that case, the agent will calculate this expected utility and it will select the appropriate action, right? So this is actually the usage of this utility in case of this utility theory. So I hope that all these rules are clear to you. Okay. So there is a paradox which is known as the Saint Petersburg paradox. So here actually giving a example that you are offered to play the following game. You flip a coin repeatedly until you get your first head, and you will then be paid $2 to the power of every flip you make, including the final one. Okay. So what happens in that case? How much are you willing to pay to participate? The question is that you are going to play this game and you are supposed to flip the coin, and once you get the head, you get the money which is equal to 2 raised to the power number of flip. So when you get the first head, you get the $2. When you get the head second time, so you have now two flips. For the first flip, you are getting a tail. For the second flip, you are getting a head. So there are two flips. So you will get 2 raised to the power 2. That is $4. And if you are getting three flips and third time you are getting the first head, you will get $8. And similarly, you can complete this table. Okay. So you need to flip the coin till the time you get the first head, and you uh, get the money depending upon the number of flips you have according to this table. So the question is, if this is the game for you and you want to participate in this game, how much you are willing to pay to participate such kind of game? So the question is, what is the expected winning in this betting game? So this is given by this formula. If you have the n number of flips, the probability of kth, and the amount of winning. So this will be given by this, and this is coming to be equal to n. Right? And you know that if n is going to n is tending to be infinity, then the amount of win, the amount of money you can win is also going to be infinity. So you find that you have a uh, you have a a very good chance of winning a great amount of money. So in that case, a rational player should be willing to pay any sum of money to participate. So if you feel that you have a chance to get a large sum of money like this, and if you are getting a large number of flips, you are permitted to have a large number of flips, then you have a chance of getting a large number of money, which is tending to infinity. So in that case, the player would be willing to pay any sum of money to participate in such game. Okay, so the question is the amount. Okay, whether this amount of money is going to be the utility for the player. Okay,